today we'll, we'll be looking at the commissioning of Sunsynk and the Freedom One battery, which is the lithium battery that we distribute with our Sunsynk. So I'll quickly share my screen. Just a second. Okay. Can you see my screen? Okay. Can can you can you see my screen? I just type an acknowledgement on the chat box. Okay. So today we'll be looking at the Sunsynk commissioning, a basic product overview of the Freedom One battery, together with uh, like the connections needed for the two systems. So okay, so for this is the aesthetics of the Freedom One battery. The different range. We'll go through them in our next slide. So this is how the battery looks like. It's a it's a lithium battery, um, locally manufactured in South Africa. So it comes with termination cables on the left side. The cable diameter it's 50 millimeter, right? And then the for 15 over 12 will shortly explain what 15 over 12 simply mean. Batteries and above, they come with two sets of cables, so you would have two positive 50 millimeter cables and two negative, making it a total of 100 millimeter cable diameter for the battery. And then in front of the battery there are two switches, which is the power on and the power off, labeled 11 and 12 on the diagram. uh, and then we have a breaker, an MCB, which is labeled 3 on the screen. and then we have an analog meter to show your battery SOC graduated in percentages of 25. So basically it is 4 bars. So if your battery SOC is less than 25, only 1 bar will shed and so on. If your battery SOC is above if your battery SOC is above 75, then it means all the 4 bars will be shaded green. So when you're powering on the battery, you first need to put up the MCB breaker, which is denoted by 3 on the screen, and then after then you switch on a button number 12 to fully power on the button, and then your SOC will be your SOC analog meter will simply show the SOC of the battery. So this is the side view of the battery. So on the side view, on the left side of on the right side of the battery, you get your DC output cables, which is the output of the battery, the positive and the negative, red positive, black negative, and there are signs engraved next to them so that you don't make a mistake in case you are colorblind. Um, and then there are 2 ports. The battery uses CAN bus communication. Uh, Please note that, because timely you'll find installers connecting the cable from the battery, the comms cable on RS-485. The battery uses CAN bus. Would also look into the pin configuration for the CAN bus when you're integrating it with the Sunsynk inverter. So the communication ports, each battery has 2 communication ports. They work interchangeably. So in case you are daisy chaining your battery, that is, we have more than 1 battery. So you simply have to daisy chain your batteries from the so the first battery, you connect first port to the inverter, the second port you daisy chain it to the next port, to the next battery, the free port on the next battery you daisy chain it to the next battery up until your last battery. And then on your last battery with the Freedom 1, you are required to install a RJ45 end of terminator. uh, the RJ45 end of terminator, it's a standard. We can use. I'm sure most guys they know the Victron RJ45 end of termination. It's the same. It's a standard RJ45 end of terminator. Basically, is to give communication to the inverter to say this is the last battery on the chain. So if you have 1 battery, like in this case, so the open port you simply wire it to your inverter on CAN bus port, and then the other port, then you install an RJ45 end of termination. So Freedom One is a wide range of batteries, uh, from home basic, that is the standard residential range which people could use for their residentials, up to business, which are big battery systems, and you can connect up to 16 batteries in parallel. In case you want to build your battery bank, when you're using the Freedom One batteries, you can connect up to 16 of them in parallel. So the nominal batteries for all the batteries is 52 volts. That is suitable for 48-volt inverters. So if you're building a battery bank for an inverter with of 200 volts and so forth, you need to connect the batteries in series. But however, if your system it's 48 volts, then you would need to connect all the batteries then in parallel. uh, with Unlike AGM and lead acid batteries, where the battery voltage is proportional to the SOC of the battery. The lithium uh, depth of discharge curve is different. It's not proportional to to the voltage. So you would find that a lithium battery would report a 10% depth of discharge uh, when the voltage is probably around 48 volts thereabout. So the voltage and the SOC for lithium batteries is it's not proportional as compared to the AGM and the lead acid. So you would find lithium batteries, they come with a management system, um, which is the PMS. So to manage the cells, because lithium cells, they're much delicate, and a lithium battery is made up of a pack of a pack of 3.3 volt cells. So for a 48 to make up a 48-volt system, the system would have 15 3.3 volt cells. So the BMS is responsible to manage those cells. So with lithium batteries, you usually get distinct faults from AGM, like cell over voltage, cell under voltage, and all those kind of cells. So basically, it means one of the cells out of 15 probably it's already at around 3.4, while the others are not are below that. And then the BMS has to protect that cell from overcharging. So you'd find your system timely. Maybe the part will give a over cell voltage protection and all that. So if you encounter an over cell protection, all you need is to make sure you cycle your battery. So lithium batteries, it's recommended that you cycle them. It's not recommended to say to always keep your SOC at 100%. So with lithium batteries, it's recommended, especially if you have more than one battery, it's recommended that you cycle them, because if you keep them at a constant SOC 100%, over time they will lose synchronization. Then you'll find that maybe your lithium battery uh, actually to be around 50% SOC, but the SOC reading or or on the inverter is quite low, or you would find different batteries with different SOC, and then uh, to give a synchronization error. So with lithium batteries, it's recommended that you cycle them. You mustn't keep them fixed at 100% for a long time. So Freedom 1 batteries that denoted as a fraction, which is for instance the first warm one is 5/4. So 5 simply means the total capacity of the battery, which is 5 kilowatt hour, and then the 4 simply means is the usable capacity of the battery. That is the maximum recommended depth of discharge. So for a 5/4 battery simply means it's a 5 kilowatt hour battery with usable capacity uh, of 4 kilowatt. Same with 10/8, 15/12, and so on up until the business range of 80/64. And lithium batteries, the recommended depth of discharge is 80%. However, you can discharge it to 90% depth of discharge, but you shouldn't do this for many cycles. It shouldn't be a daily discharge to say you discharge it to 90%. Although if you discharge it to 90%, it doesn't affect the warranty because that's the rating of the battery. But however, it's recommended that you discharge it to 80%, because if a battery is discharged to its deeper levels, when charging up, it uses more energy to charge up the battery, and then that causes the cells to overheat, and that could actually shorten the lifespan of the cells. So uh, when you're discharging your battery, a lithium battery, it's recommended that your date of discharge you keep it at 80%, unless if there is a dire need to discharge it to 90, then you can go to 90. Still, it won't affect your warranty, but it might actually shorten the lifespan of the battery. Uh, I'm not sure on how much it will be shortened, but I'll check on it. Then I'll advise in our next web. Uh, for every 5 kilowatt Freedom One battery, the the current capacity, which is the AH, it's 100 AH, because basically the battery is it's a 52 volt. So to get a 5 kilowatt, it's 100 AH, and the battery it's a 1C, which means you can actually discharge uh, draw all the 100 amps from it. So the maximum and charge current of the battery, it's 100 amps. So you can charge your battery. So for instance, on other inverters, let's say you are using other inverter which is not a Sunsynk, and you are using this Freedom One battery, make sure that your charge current, that is both DC and AC combined, does not exceed the rating. So for every 5 kilowatt module, the charge and discharge current, it's 100 amps. So make sure you set the proportionality. If you have a PV string that brings in 50 watts, 50 amps, so for grid charge, you need to set 50 as well, so that you don't overcharge the card, the battery. And the maximum discharge and charge current, it's 5 kilowatt for every 5 kilowatt module. So at 10 kilowatt, the maximum continuous charge power would be 10 as well, and so on. And then so that those are basically the key features of the batteries. If you are to connect one more one battery, the recommended size of the inverter is it's 10 kilowatt. That is for the 5 and 10. 15 to 15 and 20 is 10 kilowatt size of inverter. So you should always try and keep the proportionality between the size of the inverter and the battery bank, so as not to over drain the battery. As I've said, the Freedom One batteries, they use CAN bus communication. So and the CAN bus pins, which the major pins, which is the high and the low for the inverter, for the battery, it's 7 and 8, right? And when you're integrating with Sunsynk, Sunsynk pin allocation for CAN bus, it's 4 and 5. So the battery is not supplied with a CAN bus cable. Why? Because the CAN bus pins, they differ from inverter to inverter. So uh, there is need to crimp the battery comms cable for yourself. So all you need to do is to make sure your battery end and your inverter end. So if you are using the Sunsynk and the Freedom One battery, your CAN pass high and low for the battery 7 and 8, and for the inverter is 4 and 5 respectively. So you need a type 2 cable, and you match your pins on the battery side and the inverter side. Uh, the grounding for the Freedom One battery is pin number 6, and the grounding pin for the CAN pass for the Sunsynk is pin number 2. But the most important pins are it's 7 and 8 on battery, to 4 and 5 on the inverter. So please make sure when you are installing a battery, you take note of the CAN pass pins, because if you don't, then you would get you would get a you would get a battery comes fault on the inverter. On the Sunsynk, if you go to LMI BMS, then you won't be able to read your battery values there. So from our installation webinar yesterday, if you recall, this is how a fully installed Sunsynk inverter looks like. So basically, with your Sunsynk inverter, you would need your PV array with connected through a protection box and or a combiner box. That is, if you are using an 8 kilowatt inverter. Your batteries are connected to the inverter. They should be connected through a DC disconnector, basically a DC fuse and isolator box, such that you'll be able to switch off your battery when there is need to. And then you have your grid side with non-essential loads through an AC protection, which can be a breaker and isolator to the inverter. The same with the output of the inverter, you pass it through an AC isolator or breaker to your essential loads. That is the loads connected on the output port of the inverter. And then you would need to hook up your CT on the live wire, preferably soon after the municipal meter, such that the system measures every load that is in the house, such that you can fully utilize your PV array. So this is how a complete Sunsync installation looks like. So before power on, it's recommended that you do your checks, measure your string voltages, check your DC isolator, put on the batteries with the DC fuse off, measure the voltage, check, make sure all your electrical connections are safe. And then to power on the Sunsynk inverter, the Sunsynk inverter is a pure hybrid inverter. So you would realize that if you put on your PV and grid without putting on the battery, the display of the inverter would come on. If you set the inverter to battery no on setting, then the inverter will simply work as a grid tie inverter. However, if you are connecting battery, then you would need to put on the battery switch on the left side of the inverter. That is for an 8 kilowatt system. Uh, Once everything is powered on, um, then then there is need to program the inverter, basically to set it in a way which you would want it to work. By default, a Sunsynk inverter uses PV power to charge batteries first till 100%. From there, that's when it will start to supply your loads. By default, that's how it works. And after supplying, if after all your loads have been catered for, then it can feed back to the grid. However, it offers the flexibility of programmability, such that you can set it in a preferential way you would want it, when to use your battery, how to use your battery, to what percentage of discharge do you want your battery to go, how much SOC you would want to reserve for island mode. That is the battery SOC to be only used when the system loses grid, that is in off grid mode. um I'm sure many guys would agree with me. Sunsynk is one of the best displays in terms of aesthetics. uh so this is how the screen looks like for both the 5 kilowatt and the 8 kilowatts. Uh, it has a so all the programming and everything, programming, control, monitoring can be done on the screen. So like the inverter world is moving from just the issue of installing tiring wires and all that. Yeah, you should also be a bit creative with the programming part, because sometimes you would end up blaming the product whilst it's you who's not taking the initiative to know how the system works and how to best program it to suit your needs. So on the screen, on the display screen, uh, at the top there are four LED indications from left to right. When your system is DC connected to it, the LED will illuminate green. If not so, it will be off. The same with AC. If you have grid connected to the inverter, then the LED would illuminate green. Uh, when the system is normal, everything running fine and all that, the normal LED will come on with green. Uh, Whereas the alarm LED is an interlock, obvious with the normal. When it's not normal, the normal will be off, and then the alarm LED will come on. The alarm LED illuminates red to show that there's something faulty with the unit. Underneath the screen, we have your scroll buttons, which is basically up, down. You have your enter on the right, and then you have your escape. So basically, escape it's the back button when you are scrolling the screen. The, this is on your left. This is the screen display. Um, so on the screen, you would get at the top, you would get the customer name, uh, which you would set in basic settings. That's where you would set your customer name for the system. And then denoted 2 is the settings menu. If you are to access the settings menu, then you need to click on that gear like icon. And then 3 is the solar history, which is basically the cumulative solar production. And then on 4 you have your access system status, which is the AC load. It shows the AC load, but mainly these icons, you can use them to access the system status, which we would also look into in our next slide. Same with 5 on battery. And then on grid, then you would access the grid history, which is basically the energy yield, cumulative values for the power that has been drawn from the grid. And then on 7, it shows the bar graph, uh, which is basically the cumulative energy for the system. So you can select whether you want to view it for a month and so forth. And then this page is also used to access the system flow page, which we'll look into it as well shortly in our next slide. So, so basically that's what we've been talking about to say what what the page shows and all that. Uh, the if you click on the AC load icon or the battery icon, the one to access the status page, you would access a table like the one on the screen. This is the status page. Basically, it gives you the status of the system for all the components related to system operation. That is the battery power, charging or discharging the battery. It will be positive if it's draining from the battery, and negative when it's charging the battery voltage, the current, that is the real-time current, whether it's discharging or adding, depending on the sign, and then the state and then the state of charge. On grid, then you get your total power on grid with the frequency and the voltage and the current. And then there is city meter reading, which is basically what the city meter is reading. And then the load reading, that is if the inverter is using your grid to supply the loads on its port, then you get the power there. So basically on grid, the what's at top, it's the algebraic sum of CT and and load power. And then you get the MPPT, individual MPPT readings, that is the watts, voltage, amps as well. Same with the load. uh, and you you would also get the inverter power. So on inverter power, it is the power that is being inverted from DC to AC, whether it's coming from battery or PV. So it's the combined power being inverted from DC to AC. So this is quite a handy page if you want to basically get the view of the summary of your system operations. These values are real time. Uh, so if you are to increase loads on your premise, you'd actually get to see the values also ramping up and all that. So this is basically what that page displays and all that. Um, System flow. To access the system flow diagram, you need to click on the bar chart on the home page, as I've said earlier. So the system will basically give you an overview on how your power is being distributed across your property. So you get values for individual MPPT power readings, and then they are combined, pushed to the inverter. So the system would denote these with arrows showing the flow of current. Sorry, but let me just quickly mute this. Okay, yeah, sorry about that. Yeah, so it will best the system on the system flow, you actually get arrows which denote the flow of your current, which is basically the flow of power. And then you would get your battery with the voltage, the SOC, the watts, whether being drawn or it's being charged. And then the circle just above the inverter with 100 and 04, it means the output from the inverter. That is, this is the inverted. This is the inverter output, which is the power inverted from DC to AC, whether it's coming from the battery or the PV. So the reading the reading on that dialog would simply show the algebraic sum of your PV and or battery. So if you get 1,000 from PV, 700 is charging the battery, then you should get 300 there to show that after the PV charges the battery, the 300 is being pushed to the loads, or it will be or the battery and the PV will be adding up to supply to the loads. And then on the top branch, you get your aux port. That is where you connected your generator or your auxiliary loads. So the direction of arrow will show whether the system is a generator input to the system, or alternatively to show the power which is being used by your aux loads at a given time. The second branch, which is 100 watts UPS, this is the load output of the inverter. This is basically the critical loads that you connected on your system. So the value reading there would show the amount of power being drawn by your essential loads, that is power being drawn through the load port of the inverter. And then the bottom battery, the one with which is hooked to the grid, this basically shows your power at the city point, right? So where you hooked up your city meter, the power reading will be displayed there with the grid voltage and frequency. And then the watts positive, it means the grid is supplying to the network, and negative, it means the system is feeding back to the grid. So please, it's quite handy, especially if you want to check if your system is properly installed, and which part of the system is using much power and all that. So our next, we'll quickly look at the programming, which is basically the heart of the system. which is the settings page. That is the setup page. So to access the setup page, you would need to click on the gear-like icon on the top right of the home screen, next to help. If you tap on it, the settings page will be displayed. Right. So the settings page is 8 main sub menus. The first one being basic. So on basic, basically, you set your company, your client, customer name, your date, your type, and all those basic settings and all that. And then on battery, the main things that you need to set on battery is the battery type that you are using, whether lithium, AGM, or gel. And then the mode of, if you are using lithium, then you select the mode of communication that to the BMS that we are using, whether it's a CAN bus or an RS-5. For a lithium battery, you need to select CAN bus and make sure your comms cable from the battery is wired on CAN on the inverter. And then the next icon is grid. Usually this parameter you leave it as default because the inverter produces a standard of 230 volts at 50 hertz. However, if you want to alter the lower cutoff and upper cutoff voltages, your protection voltages, and your protection frequency, you can actually set the settings here. Or if you want to use 110 volts, if you want the inverter to produce 110 volts, then you can go to grid and select the mode to 110 volts. There is one client who was inquiring about getting an inverter which produces 110. That's how you set it, but that it's rare in occasions. 110 volts, it's used with 60 hertz in the United States region. And then on system mode, we'll look to this in detail because that's where much of the programming is done. Basically, you set how you would prefer your system to work. We'll look into it in our next slides. On advanced, that's where you set your multi-inverter configuration. That is, if you are to connect your inverters in parallel, then that's where you do the settings on advanced. And then on Oxload, we covered advanced and Oxload on our yesterday webinar. On Oxload, then if you are using the Oxgen port, then that's where you'd configure the port parameters on Oxport. Fault codes, you should also be familiar with this sub-menu, because basically to list all the faults that the inverter is and the description, then you can quickly refer to the installer manual for the recommended resolution of those faults and the detailed description on what could cause those faults. And then on LMI BMS, when you are using a lithium battery, the battery BMS values are displayed on this sub-menu. So whenever you connect and configure your lithium battery, you need to go to LMI BMS and check if you have got a, a success in the communication. That is, if you could actually read your voltage, your current, and and all your BMS status. If you are still reading zero, then you probably need to check if the battery is on. That is, and if the communication cable that you are using is properly crippled. That is inverter side CAN bus 4, 5, and then battery side. If you are using lithium, Freedom 1, 2P7, and 8. And you just need to check on that and make sure you get communication on the part. So this is basically the description of those sub menu icons that we just covered. When you are connecting your battery to the inverter, as I have said, after you've hooked up your battery, you've hooked up your communication cable, then you would go to settings, click battery, and then on battery type, then you need to select the type of battery. So basically, those are the type of battery that are compatible with the Sunsynk inverter. which is the lithium, the AGM, properties and the lead acid properties. They're basically the same. So if you are using a lead acid battery, you would use AGM, and then you would select which control would you want the battery to use. Do you want the battery to use percentage in you want the system to use percentage to calculate your battery SOC and cutoff voltages and all that, or you would want it to use the percentage. If you are using the system as a grid tie inverter, then you would select no battery uh, for that, so that the system can be used as a grid tie system. So if you select lithium or whichever battery configuration that you select, on the right side it will pop up a page for that specific um, selection. In this case, it's lithium. So you would need to set your battery capacity. For Freedom 1 batteries, the battery specifications are labeled on the nameplate of the battery, which is on usually, okay, in all instances, it's on the right side of the battery. There is a nameplate there, or alternatively, you can refer to the manual of the battery. So if you're having a 5/4, you would know your battery capacity in AH it's 100, your discharge current and all that. So all those parameters they'll be listed on the battery. So for whatever battery configuration that we are using, refer to the nameplate of the manual of the battery, such that you would set the charge and the discharge and the capacity of the battery. And then the communication mode, if you are using CAN pass, then you would select CAN pass. If you are using RS-485, then you can select RS-485. Protocol, you leave it as default, and for you can leave it as default 1. After you've done your settings, then you say okay, basically to submit and all that. So
Ryan,
when
Ryan,
yes,
sorry, just before you carry on that slide there, was there ever a Sunsynk installed with a Tesla? Because I just want to know, can the Sunsynk be used with the Tesla? Because obviously the Tesla works as an independent battery with the whole gateway
yes.
controlling the whole battery. So in your setup here, would you just then select no battery?
If you select no battery, then it means the system would act as a grid tie.
Okay,
So
so that's great because that's what.
it won't draw anything from the battery. For the Tesla specifically, we need to check, or else what is recommended is if the battery doesn't support CAN pass or RS-485, you would connect it as you select AGM, and then AGM basically has more features, because when you're using the lithium battery option, all the charge settings, the ramp down and all that, they are basically set, they are basically monitored by the BMS. So the inverter would actually pull those values from the BMS. However, if you are using a battery and you cannot get it configured with CAN pass or RS-485, then you would select AGM, and then you would set the properties of the battery manually, like the cut off and all that. Then you need to set those manually.
Okay, thanks.
Maybe I might just add to that, Brian. The Tesla Power comes with its own battery inverter. So if you want to use the Sunsynk, you will just have to use the Sunsynk as the grid tie, and then you AC couple the Tesla Power. We will check again and confirm, but I think that would be a more suitable configuration, because you can't connect that a hybrid inverter straight to the Tesla Power when it already has got its own battery inverter.
That's right. Thanks, Tuba. Because the one thing that's important for me is I just want to understand the frequency shifting as soon as the Tesla battery reaches its full capacity, especially during the day. Will the Sunsynk inverter then accommodate that frequency shift and switch off when the battery is full, or won't it accommodate that? Because I know there's specific settings that we need to set up with the Solar Edge to be able to do that. So if we can just maybe after this training, do a bit of investigation into that and just see, I'll appreciate that. Thanks. Because I've got an application that I need to do like that now.
All right. No, I'll check for you, but it's definitely going to be an AC coupled system. It's not a hybrid.
Yes, no, I agree with that, yeah. I agree with that. I just want to understand the frequency shift from the Sunsynk side.
Okay.
Thanks for that. Okay, so after you've hooked up your battery, if you're using a lithium, then you can go on LMA PMS and then check if you could actually read your battery parameters, the charging current and all that on LMI PMS. If not so, then you need to check on your cable, and if the battery is powered on, and check whether the battery supports CAN bus or RS-485. If not so, as I have said, then you would need to set up the battery as an AGM, and then you need to configure all the parameters manually. And then our main programming page, which is the system mode, it's accessible on settings and then system mode. So this is basically how it looks. This is what you get when you go to system mode. That's where you do all your programming. So the first tile from top, that is the top row, from left you have your time. So these are the time zones you'd want your battery to perform or to work in a different way, in a preferred way. And then on power, you have the power limit. You can set the inverter to produce specific power for certain time zones. You can cap your inverter to say at night you would want your inverter to only produce 2 kilowatt, and then the balance of it would be simply be taken from grid. And then the SOC on the battery SOC or voltage, depending on the battery type that would be used. Basically here you'd set the reserve SOC, like the cutoff SOC you would want your system to draw your battery to. So if you set your SOC at 100%, it means during that time period that you would have set, then the battery would not draw anything. The system will not draw anything from the battery. If you set it, for instance, 50%, then for that specified time zone, then the system will draw your battery up until the specified SOC. And then on the grid and gen tiles, you would select for the specific time zone which mode of power would you use, like source of power would you want to use to charge your battery. If you want to use the grid to charge your battery for a specific time frame, then you would tick on grid. If it's the generator, then you do the same. And then on our left side, just under help, the first icon is zero export. Like it's already defined. If you do not intend to export any power to the grid, then basically you need to just tick on that box. Then the system will not feed back power to the grid. And then sol export, on sol export, you tick if you want to feed power to the grid from solar, then you tick sol export. And then limit to load only. On limit to load only, the inverter would only produce power and supply the backup port, which is the load port. So in this scenario, the system will only use PV and battery to supply your essential loads. That is the loads connected on the load port. So if you have non-essential loads like stoves, geysers, pumps, and all that connected before the inverter on the grid line, if you intend to supply them with PV or battery power, you should always keep limit to load only off. And then zero export power. This is basically the float power that you can draw constant from the grid. This is actually this could be also used for peak shaving when you are using grid, right? Even if you connect your generator as a grid input to the inverter, that is maybe through a changeover switch or in an off-grid scenario where your generator is where your generator is where your generator is quite small, then you can actually set zero export power, maybe 1,000 watts. Then the system would first draw 1,000 watts from the grid or generator. After then, that's when it will start to add PV power onward. So the zero export power, it's used as peak shaving. Other people would usually use it. For instance, peak power rate tariffs, they're quite higher than standard. So you would charge his batteries during standard hours, mainly at night. And then during peak hours, then you would set zero export power such that the system will take minimum from the grid, that is at high tariffs, and then use up the batteries with power that he bought during low tariff times. And then the maximum cell power, this is the capping of the inverter. You can cap the size of the inverter, like this maximum power that the inverter can produce. Usually this value you would set it at the size of the inverter. For a 5.5, you just need to set it at 5.5 kilowatt, 8.8 for an 8. That's the maximum power that the inverter can produce. If for instance you want to limit your inverter in 8 kilowatt to only produce 5 kilowatt, then you can set the max cell power to 5 kilowatt. Then the inverter will be kept at a 5 kilowatt 5 kilowatt product. And then on the underneath, we have priority load. As I've said in the at the beginning of our webinar, Sunsynk by default first charges your battery to 100%. Afterwards, then it supplies your loads. If there is surplus after supplying both critical and non-critical loads, then that's when it will feed back to the grid. So if you intend to take priority to supply your loads first, then you would click on priority load. Then the system basically would use PV power first to supply your loads, that is both critical and non-critical loads. After then it will charge your battery, and then when there is surplus, then it feeds for the grid. I think usually this is the ideal setup for a system, since we would want to use our PV to supply our loads first, and then charge our battery to 100. But if you feel like you would want to first charge your battery to 100, and then it's thereafter, then you start using your PV to supply your loads, then you leave priority load unticked. And then use a timer. If you intend to use the time frames that you have set up there on the tile power SOC grid gen, basically on the main window of the page, if you need to use those preferred timelines, then you would select use timer. If not so, then the system would operate would operate uh, without any time limits. Basically, to either charge your battery to 100 and supply your loads afterwards, or it will supply your loads and try charge your battery to 100. If the PV is insufficient to supply all the loads, then it will drain the battery up until the date of discharge, or to supplement the deficiency in the load network. So that's basically the system timer. How to use it, we'll just check on a few scenarios. In the example up below, the system basically it's for peak shaving, sort of. So the system wanted to do, okay, one other thing, how you read these time zones. For instance, on the screen, the first line, it's 8 o'clock, 4,000 watts, 100% grid. And then the second time zone, it's 11, 5 kilowatt, 50%. So the parameters in terms of power, SOC, and grid set on the upper tile is valid from that time to the next time zone. So the parameters set at 0800, they are valid from 8 to 11. And then the parameters set at 11, they are valid from 11 up until 8 o'clock the next day. So that's how you read these these time zones. So for this system, so the battery is being charged to 100% from the grid and PV from 8 to 11, and then being allowed to supply up to 4 kilowatt of battery to the essential loads on the load port until the battery SOC drops to 50%, right? So what the system does? So from 8 to 11, the system would charge from grid. Obvious PV, charging from PV is constant. In this case, priority load is not ticked, right? So whatever PV power that comes, it's first pushed to charge your batteries. And then at the same time, it uses grid as well to supplement PV to charge your battery. The grid current and the PV current combined, they should exceed the maximum charge rating of the system that you set on battery setup. So from 8 to 11, the system will charge from PV and grid because the grid box is ticked, right? Up until SOC 100%, and the system can produce power of 4 kilowatts, right? From 11 to 8 o'clock, the system can draw power up to 5 kilowatt. Sorry, I wrote 4 at the top. So the system can draw power of constant 5 kilowatt from the battery. It can produce power, that's inverted power, regardless whether it's coming from the battery of PV, of 5 kilowatt supply to the loads, right? In this case, limit to load only is selected. So it means this system at this instance, it's only supplying loads connected on the load port. That is the essential loads. So whatever power the system supplies to the loads goes to the load port only. It doesn't supply the non-essential. So it will supply power 5,000. If the loads require 5,000, it will just supply power up until the SOC drops from 100 to 50%. At the same time, it's not feeding anything to the grid because zero export is selected. And then at the grid point, it should always draw a constant of 100 watts from the grid. So the zero export power section is quite useful, especially I'm sure most residential installers have experienced the power meter being tripping because of trickle power and all that. So if you set your zero export power, usually trickle power ranges from 50 to 200 watts thereabout, depending on your load profile and how your load spike and all that. So, but for a standard home, the peak power wouldn't be more than 100 watts. The trickle power, sorry, wouldn't be more than 100 watts. So the trickle power is caused due to the hysteresis in the control loop. So logically, the meter has to measure. Let's say the loads were 10 kilowatts, suddenly they drop to 5. So the meter has to measure to say the loads have dropped, they're now 5 kilowatt. Tells the inverter the loads are now at 5 kilowatt. The inverter has to ramp down its production such that I maintain zero at grid. Guys, the loads have dropped. The load has dropped to 5 kilowatt, ramped down to 5 kilowatt. So that hysteresis uh, by the system is supposed to do that within 2 seconds. So 2 seconds, it's a long time maximum if it has to ramp from maximum to minimum production, which is from rating to 0. You should do that in 2 seconds. So the hysteresis during that time, some trickle power would flow to the grid side. However, it's not considered as fit in under the NRS regulations because fit in has to be constant for more than a minute. So if you have sensitive power meters, mainly in our market being Conlog, you would get a scenario where the prepaid meter would trip because of reverse current and so forth. So if you set your zero excess power to 100, so it means the grid is always fitting 100. If there is a trickle power less than 100, it will simply subtract from 100, and then it doesn't go back to the grid because the grid was already fitting 100. So if your load are quite spiky and the spikes are huge from 10 kilowatt coming back to 3, then you might consider maybe taking the zero export power to around 200, 250, depending on the system load profile. So this is quite a handy setup for reverse meter protection of prepaid meters. However, with the conlog meter in the market, if you install a system and it's trickle fitting to the conlog and it's tripping, you can simply contact us. Then we can make an application to conlog to specifically widen the tolerance for your meter to accept that trickle power. So basically, that's how the system, if you set up the system like this, so whatever you set on a line applies between the time period from that time to the next tile. So as I've said, 8 to 11, the system will charge from grid and PV, SOC up until it gets to 100%, and the system can produce 4 kilowatts to the loads, to the load only, because it's selected on load, limit to load only, and it will not feed to the grid. And then from 11 to 8 the next day, the system would supply 5 kilowatt up until the SOC, battery SOC drops to 50%, and it will only supply loads only. So the system doesn't take priority to loads. Whatever PV comes to the system, the first thing that it does, it needs to charge the battery. It pushes all of it to charge the battery up until it gets to 100 before supplying loads. So another scenario will be to supply power is supplying the non-essential loads, and maximum power of the inverter is 8 kilowatt. So in this case, you are supplying your non-essential loads as well. The inverter is connected to the grid, right? Because the inverter can only supply non-essential loads when it could acknowledge grid on the inverter. So the inverter is an anti-islanding feature. So the moment it loses grid, automatically it cannot supply the non-essential loads. It will only supply the loads connected on the load port. Those are the essential loads, the dire loads that you need when you have a load shedding. But in this case, so if you want your system to produce to maximum supply, take priority of the loads, right? Take priority of the loads first. Do not feed back to the grid. You don't restrict the SOC of the battery. You'd want the system to drain the battery up until it's empty, charge it up until 100, and then you have your zero export power at 100. So the system would always draw 100 kilowatt from the grid, and then the system will supply maximum power to loads first. After the loads they are catered for, then it charges the battery. If there is surplus, then it will need to throttle it because you don't want it to feed to export. Then that's the setting that you need. So this is the basic system, ideal system setup that everyone would need when installing a solar system to say, I need to cut down on my grid consumption. So when I install the system, I expect to produce to maximum, supply my loads, charge my battery. At night when there is no PV, then the system would simply take from the battery, supply my loads up until I drain the whole battery. I fully utilize my depth of discharge. The next day, PV comes back, charges my battery and all that. So that's how you would need to simply set the system. So from this basic setup, if you would want to reserve an SOC for your battery, then you would need to select user timer, and then select the specific, maybe on all the times, then you set this. Let's say you want to reserve 40%, then you just say 8 o'clock, power maximum of the inverter, SOC 40%, then you are not charging from the grid in any time zone. So the system basically what it will do, it will use your PV, supply loads first, charge your battery, and up until it gets full, or discharge the battery as long it's above 40%, and then reserve 40% for load shedding if there is need. If you don't want to feed back to the grid, then you select your zero export. So the programming is quite simple. I think the wrong term they use. The moment they say programming, everyone thinks it's a hard thing, and then everyone wouldn't pay attention to minor details on it. So this is basically the explanation of these tiles, the boxes here, and then so this is basically the same set. Another scenario where you'd want to charge at night and then discharge it during the day, but in this time you are not limiting to load only. You would actually use your inverter to supply your non-essential loads as well. So this is basically the same setup. So in this setup, from 12 midnight to 6 in the morning, you charge your battery from grid up until 1000, and the system can produce power of up to 2000 watts. And then from 6 to 12 at night, then you can discharge your battery up until 20% at constant maximum power of 2000, and so on. So you can actually play around with the time zones, but preferably you play around with a fixed, because some other guys would have let's say it's from 8 to 12 I need my battery around 100, or maybe around 80. From 12 to 4 I need it to ramp up to 100, so I start at 500 and so forth. So you can play around with different time zones, but just not whatever you set on a time on that timeline applies between that time and the next timeline that you have set. So and then the other so this is basically that scenario where in a scenario where you would want to use the system as a UPS, right, with grid connected to the system, and then without PV. So the only thing that you'd need to charge your battery to 100, limit to load only, and then supply your load. So this is basically if you are using the battery without PV as basically as a UPS, you need to select limit to load only, right? Then the system with the zero export. So the system will simply use your grid, charge the battery. When the battery is full, then it will only use it to supply your loads. And then peak shaving, I'm sure we have touched base on it during our webinar. So peak shaving basically is a technique of buying power during low tariff and using it during peak hours. So this technique can also be used with generator. When you have when you're integrating your system with a generator, and your generator it's smaller than the size of the system. Let's say charging the batteries at the same time, supplying the loads. But you would know that if you use up your PV, your batteries at night, let's say it's at night, you use up all your batteries, they will only last you an hour. But at the same time, if you connect the generator, it won't be able to supply the all of your loads. Your generator is quite small. So you can actually use the peak shaving feature where you would draw a constant power from the generator, and then the system won't use. If the system needs to charge the battery or supply loads, it will not draw more than the peak shaving setting. For instance, your generator is a 1.5 kilowatt, your loads they are 2 kilowatt, right? So you would know that if you lose your battery bank, then you are in darkness, because the generator won't be able to supply those loads. So you can set a peak shaving of 1,000, and then the system will draw 1,000 from the grid first, and from the generator, sorry, and then use the other the deficiency from the batteries. That would actually help you to use a smaller generator to the system. Or alternatively, you can use this inverter, this peak shaving to supply excess power above your rating. For instance, if you have a fixed supply of 20 amps, 10 amps, and your consumption, your demand is 15 amps, so you can actually get to draw, or maybe there is a limit, like to say if you draw more than 10 amps, then the charges, they are different. If you draw more than 30, those are different kind of scenarios with in the industry. So you could actually peak shave your system to only draw the maximum that you want from the grid, and then the inverter, then from there is the deficiency to the the load. So that's basically how you can use this peak shaving feature on the Sunsynk. So if you are using genset as a peak shaving, then on aux slot, then you need to select gen peak shaving and set the power, the peak power that you'd want to draw from the generator. If you are using the grid for peak shaving, then you basically need to set it on zero expert power. Set your peak shaving power on zero export power. Then the system will simply draw that power from your ESCOM. Okay, sorry. And then basically that's all basic setup regarding the Sunsynk. However, if you find any challenges with the setup and everything, we are a call away. You can just give us a call, then we'll quickly assist you on how to best set your system, how to best set your system or on the way you want it to work. But these are some of the basic setups that you'd encounter on the on the market and all that. So I'm not sure. Toba, are there any questions on the chat box?
Brian, I just got a question quickly on an application. I don't know if maybe something we can discuss afterwards as well. But if you in an off-grid scenario, okay, there's no grid available, and you just actually want the generator as a backup if the batteries drop down to a certain state of charge, okay? Obviously, you will still tick the zero export because you don't want to feed back onto the generator. But your zero export limit then, that wattage that you set in there in the export limit, what would you set that to? Because obviously you don't want the generator to run all the time and use 100 watt from the generator. You want the generator just purely as a backup when the state of charge of the battery reaches its low limit. What would you do in that instance?
Okay. Okay. So if
Murula-san has just become a
okay. Okay. In that instance, if okay, in that instance, if you are running a generator and you want to use it for only as a backup when the batteries are low. So in an off-grid setup, then the generator is connected as a grid, right? And then you can on the setup page. I'm sure it was there on the yesterday slide. When the system battery reaches a lower value, then you can activate to power up the ATS, and then the generator would come on. But now when you are running the generator for peak shaving, like when you're running the generator and you don't want to feed back to it, that's when you would set that zero export to a value. Usually every generator has a recommended minimum load that it should supply, mainly around 30%. Then if you calculate the size of your generator, then you can put it there, and then the generator would, that is in a scenario where the generator is running consistent to assist your loads. But in a scenario where you would want your, when the batteries run low, and then you'd want your generator to come on, run for a certain time, and then switch off. Alternatively, you can either set the times as a time zone to say the generator comes on maybe an hour or so, runs up, charges the battery, switches off for a certain time zone, and then comes on again through the ATS and all that.